Hello, good afternoon to you all, and you're all welcome once again to our session on database modeling and design with SQL.
Good afternoon, Carlos.
Hi, Mohammed. Yeah, so we've been looking at this for the past 7 or 8 weeks, I think. We've been looking at how to model database, mainly focusing on the logical and conceptual design. Today we'll be looking at a very critical part of the design process where we look at the constraints that binds the data, that ensures that the data that you are storing in the databases is accurate and is consistent. So there are some constraints or rules that we apply to ensure that the data that you are storing there is good. We'll look at a few of those ones. So we are still at the logical design stage. We call that the relational integrity constraints. The relational integrity constraints. So I want to break it down. First, about the relational database. We say it stores data in the form of logically related two-dimensional columns. Two-dimensional tables are just tables that are represented in rows and columns, just like you have in any spreadsheet program like Excel. So that's how the relational database stores data in 2D tables, but they have to be related anyway. Then we talk about information integrity, where we look at the trustworthiness and dependability of the information or the data that you are storing in the database. Then the integrity constraints talk about the set of rules that can help maintain the quality of the information. Three things: relational database, information integrity, then the integrity constraints. They come together to form what you call the relational integrity constraints. That is the set of rules that are used to ensure accuracy and consistency of data in a relational database. So we are going to be looking at some of these rules that the database designers or the team applies to ensure that the data is consistent. Now, the reason why we need to look at this, at the beginning, when you are building the database, you normally come with a structure. When you start performing operations like inserting data, updating data, deleting data, sometimes the structure gets exposed with inconsistencies. That's if you don't build your structure well. If you don't put in the appropriate constraints to ensure that the data would be consistent over a period of time, then it gets exposed, and that's when you start finding errors in your database. So you're going to be looking at that. There are four main constraints under the schema-based constraint. Apart from the schema-based, we have what we call the application-based constraints. Those ones are mainly applied by the developers. So the developers apply that on the forms or the program that they design to interact with the database. We are going to be looking at what we call the schema-based constraints. There are four main constraints. We have the domain constraint, the key constraint, the entity integrity constraint, and the referential integrity constraint. We'll start with the domain constraint. That we looked at from last week. It mainly talks about using valid data from the applicable domain or from the right data type. So we had an example of an employee table with ID, name, date of birth, sex, and the department. When we look at this, we should be able to identify that there are some data that are not consistent or doesn't apply or doesn't follow the right data type with the other ones. The first one we would identify is for employee number 3, whose sex is showing 007. Whereas the others are showing male and female. This shows that this value here is not consistent with the data type, or it doesn't fall within the applicable domain. This is something that you need to put in place so that the database doesn't accept this kind of data. It doesn't only apply to data type, it applies to the format, the data format. So this is date of birth. The designers are using a format which is, we call the YYY, the MM, and the DD. Then another one of the records here showing FEB in a different format, the month, the day, and the year, which doesn't follow this particular data design or this format, meaning these two here do not fall within the domain of this particular, their attributes. So the domain constraint will prompt these so that when you are making such an entry into the database, it prevents it. Because if it accepts it, then you are going to have a lot of inconsistencies in your data. So the correct thing will be done, it would prompt you and you would enter the appropriate one. That's it with the domain constraint. Let's move on to the key constraint. Key constraints, so we've talked about it for some time. We say each row of data should have attributes whose values must be unique to help identify the rows in the table. There are times that you could have several keys that could qualify as the key attribute. We call them the candidate keys. When you are faced with such a situation, you need to choose only one of the keys to become the primary key. We'll look at an example here again. Still the employee. In this table, we have ID, name, date of birth, email, and department. In a typical case, we could have ID and email as unique keys because no two employees would have the same ID. The same way no two employees would have the same organizational email or company email. So the ID and the email, we call them the candidate keys. When you're implementing the database, you can't use the two as the primary key. You can only choose one. You can only select one from the two to become the primary key. So in such a case, you just select one of them to become the primary key. There's no strict rule about selecting the primary key, but there are some recommendations. Usually people advise that you use the one with the less number of characters, and it's always better to use the one with the numeric data type here. So this is it with the primary key. We derive the primary key from possible candidate keys. It's not always that you have multiple candidate keys. Sometimes you would have only one, and you can use that one for your primary key. There are times that you might not even have a natural primary key in your table. So we implement something we call the artificial key or the surrogate key. That one with only increments as you insert the data into your database. Let's go to the next constraint. We call that the entity integrity constraint. It says the primary key attributes of a relation cannot have null values. It cannot have null values. Null values are values that are blank or empty. They don't have any content. So we are saying that the primary key attribute cannot be null. This is because the primary key is like the identifier. It uniquely identifies the record. So if it is null, that means the record cannot be identified. We could liken it to maybe a student who doesn't have a student ID. Then you are not qualified to be a student because you don't have an identifier. Or maybe an employee who doesn't have a staff ID or employee number. Then that employee doesn't really qualify. Okay, but that would depend on the policies of the company or the organization anyway. Yeah. So we would have something like this. There's employee table, and we have this person here who doesn't have an ID. So when you structure, we put in the right constraints, the database is supposed to reject this particular record from going into the database. If your database accepts this, then your database is not implementing the right constraints. And that will lead to inconsistencies in your data. So you need to put in the right value for the primary key. Now I'll move on to the third one or the fourth one, the referential integrity constraint. This is one of the most important constraints that are implemented in the database. All the three that we've looked at deal with just one table or one relation. The referential integrity constraint combines data from two or more tables. That is more like is the measure of the consistency of data within a relationship. In most databases, you'll find more than two tables in the database. If you build a database and there's only one table or one relation, then you might as well just use a spreadsheet. It's not really important to use the database. If you have two or more database tables in your database, then you would end up implementing this referential integrity constraints. It works with two main concepts, what you call the primary key and the foreign key. Then one of the things that it tries to prevent is, it says that the foreign key value must reference a valid existing primary key in the parent table. I'll do a demonstration of that now. Just keep this in mind. The foreign key value is used whenever a foreign key value is used, it must reference a valid existing primary key in the parent table. So let's look at this. We have two tables here, employee and department. Employee has ID, name, date of birth, email, and the department ID. Department has an ID also, a name, and location. Now let's look at how these two combine or how they connect with each other. We'll take two examples with this one. The first one says, what is the department name of employee number 5? What is the department name of employee number 5? Where is employee number 5? That is employee number 5. Now we'll try to trace the department name for employee number 5. When we consider only the employee table, we would not be able to determine the department name. We could determine the department ID, but not the name. That means we need to connect to the department table to be able to get the department name. So this is what will happen here. What do we see? We see that it traces from the ID to the department ID, which is QC, comes down to the department table and finds where it relays the QC to get the department name to be quality control. Take note, it is using the department ID here to connect the ID of this department. Let's look at another example. What is the location of the department of employee 003? Where is employee 003? That is employee 003. Then it tracks the department ID is XY. Now it comes here, it scans through the list of departments here, it doesn't find XY. Then it goes back because it doesn't find any matching ID to the department. That means that there's a problem with this employee. What is the problem? Because this XY doesn't have a valid or existing value within the list of departments. It's just like saying employee number 3 says he belongs to the company, he works in, let's say, the sports department. But in the company, in the list of departments, there is no sports department. That means this employee number 3's data here is questionable. We can't accept it. Referential integrity constraints would prevent these kind of things from happening in your database. It prevents these kind of inconsistencies. So what do? We identify that the department has ID as the primary key. Now this department ID here connects to the primary key. We say that this is a foreign key. So this is a foreign key, this is a primary key. In every relationship, the foreign key connects to the primary key. The foreign key would always connect to the primary key. That is why this XY here had to find an existing primary key here to connect to. So any anytime you have an attribute that connects to the primary key of a relation, then the attribute becomes a foreign key. With employee number 5, QC found a matching matching value over here, and it was able to get the quality control. Employee number 3, XY, didn't find one, so it had to go back, which made it invalid, meaning that this employee number 3's data shouldn't be existing in our table or in our database. This is the whole concept of foreign key and primary key. Primary key, we say that it identifies, uniquely identifies the department. Any other attributes that connects to it would be a foreign key. In every relationship, you need this link or this connection between the foreign key and the primary key for the relationship to take place. Without it, you can't connect data from two different relations or two different tables. So when you are implementing your database, always make sure that you put in this constraint. Maybe in one of the sessions where I do a demonstration in SQL, you'd see how these constraints is implemented. So you implement this constraint to link to the primary key. So anytime you are making an entry, maybe employee number 7 comes and you are putting in the data values, whatever data value that will be specified for department ID would have to be verified with the list of data in departments before it is accepted. If it doesn't find any existing department ID in the list of departments, it rejects it. Then you make your corrections. Referential integrity constraint is very key. It's very important when you have 2 or more relations or 2 or more data in your database. So in conclusion, I'm just showing you an image of the database designer or the architect, where he's putting his team in different groups to look for files or tables. In a lot of cases, you find that your data will be scattered in so many tables. That is how data is normally structured. So sometimes finding the data that you need is not always an easy task. Sometimes it requires planning, teamwork, and a lot of hard work. But if your data is structured well from the beginning with proper documentation, it's easy for anyone to look through and follow all the relationships that exist in your database. So next week, I'll be doing a demonstration of how to design a model with visual paradigm. So we'll pick an example, maybe we'll use the same company example. We'll model the entities, the attributes, and the relationships in visual paradigm and how the ERD would look like. Yeah. Okay, so if you have any questions, you could unmute yourself and ask your question, or you could type it in the chat, or if not necessarily a question, feedback or any discussion, any comment, you could put that in there. Any questions, please?
Carlos, I have a niggling question to ask.
Go ahead, please.
Good afternoon, and thank you very much for this session. You're amazing. Thank you. So, you know, when you said that for every foreign key, there has to be a connecting primary key, yeah?
Yeah.
And I think you said something about if the attribute, I'm not sure if I'm using the right terminology here, but if you're not able to find the right value in the primary key, then the input or the data is wrong.
Yeah.
What happens then when it's wrong? Does that mean that the developer has to go back and investigate it, or what do you do?
Okay, so when the entry...
I'm also thinking from a BA perspective as well. Sorry, I'm also thinking as a BA, what happens in a product, or say in a delivery, where, say on a data integration project, where the company that's integrating the data is not able to find the value within the primary key. what role will a BA play in ensuring that that is being put right? Apologies, I'm thinking and talking.
Okay. So what usually happens is the data architect is supposed to enforce this or implement this whilst he is implementing the database. But the role that the BA plays here is during the modeling stage, the team comes together to decide on what constraints to implement. So here, the BA is supposed to know that, okay, we can't allow entry of an employee who doesn't have the right department, like this example that we are looking at. So the BA would prompt the developer that we should implement this kind of constraint. But the developer would also have to know that they need to put in these kind of constraints anyway.
So as a BA then, how would I phrase my questions so that, because I'm very new to all of these, how would I phrase my questions to ensure that the developers are capturing that business constraints? Do you know what I mean? How would I phrase my questions to both the business and the developer? Would I gather the constraints requirements from the business? Okay. That's what I'm trying to say.
Yeah. Okay. So you, the BA, you are supposed to talk to the SME or the business person to understand all the business constraints or the operational constraints. Then you discuss, then you now take this to the developer. Now, not all the constraints would have to be schema-based. When I say they are schema-based, have to be implemented in the database. Some of them are implemented in the application that would be taking the data and storing it in the database. So the developer here would have to know which ones to implement in the database and which ones to implement in the application. Your duty as the BA is to collect the constraints from the business or the SME and then communicate all of these to the developer. So you just report the constraint, the business constraints. So let's say, for example,
right, thank you.
Yeah, okay. Okay, I think there was a question here. Okay, go ahead. Sorry.
Hey, Carlos the Don. How are you, man?
Hi, Will. I'm good. How about you?
I'm fantastic, man. Thank you for today's session, man.
Yeah.
You know, just before you wrapped up, you said something about extracting data from the database can be very difficult and hard work. Yeah.
Mm-hmm.
Now I'm thinking, there should be a quicker or easier way of extracting a particular data that one is looking for from a database than, like you said, going in the hard work you made it sound like. I mean, there should be it couldn't be like, there should be
It's 5 o'clock.
There should be a way of doing that, either querying for a particular data or extracting a particular data than just like sieving through the whole thing. I'm not too sure whether I got you right.
Okay, so the data retrieving process is not very hard as I'm making it sound. It's very hard when the data is not structured well. That is when the modeling process doesn't go well. But if your data is structured well, it's very easy to write the queries to pick out the data or to fetch the data from the database. So in all cases, even when the data is spread in so many tables, once you have your model, whether it's the visual in the entity relationship model or the relational model, or even just the data dictionary, you could just follow or be able to identify the whole structure, and you can write your queries to fetch the data. But it might not necessarily be a lot of hard work. It's not a very manual work, it's an automated work, but you need to do a lot of thinking to be able to understand where to find each data. Yeah.
Right. So in storing data in a database, does it not mean that there is no, like you said, unstructured, but if it's structured, like organized or categorized in a particular way, then Is there no way of storing this data in an organized way?
Yeah, so these are some of the constraints or the processes that we are looking at to ensure that the data is structured. Now, the reason why I keep stressing on the structured and the constraints is this. The database is there. The database doesn't force you to do the right thing. The database assumes, or the DBMS, let me put it that way, the software, that is the DBMS, assumes that you know what you are doing and accepts anything that you give it. So it is you as the designer or the data architect to put in the right data or to model the data the right way. If you can build a database without the primary key, the database or the DBMS will accept it, but it would mean that your database could accept duplicate records. The database will not say anything. It assumes that, oh, maybe that's how you want it. But if you put the right constraints in there, if you put in the key constraints where there's a primary key, anytime a duplicate entry is being made, it would reject it.
Right.
Yeah.
Right. Okay. Right. Thank you very much.
Yeah, thank you. Okay, someone is asking just to add, does tuple mean record? Yes, tuple means record. Tuple means record. Yeah. Abi, okay. Abi asked about, does the primary key and foreign key help to query data to check for duplication or missing key? Yes, it does. The primary key does that. It checks for duplication. And the foreign key ensures that the data between the two tables are consistent. Yeah. Okay. Do you have any more questions?
Carlos.
Yeah.
The foreign key and the primary key relation, is it one-to-one, or it can be a foreign key to many primary keys?
It is not one-to-one. It can be, okay, usually it is one foreign key to a primary key, to one primary key. But you could have a lot of foreign keys connecting to one primary key. So in that case, you could relate it as many to one.
Okay.
So for example, in the example we saw, if we had, let's say, 4 tables and all of them are connecting to the department ID, then we would have 3 foreign keys connecting to just one department ID, which is the primary key. Yeah. Okay, so if there are no questions, we could end our session here, right? But before we end our session, on Mondays we have the agile testing and automation, and on Tuesday we'll be having the business agility, focusing on the SAFe framework. Next week we'll be having our spotlight section where a guest speaker would be joining us to discuss the SAFe framework. Yeah, so please try and log into the session next Monday and Tuesday. William, do you have something else?